Hello guys, so in the previous video we had this program. So in this video we'll be trying to implement things like multi-threading, and we'll try to make this program faster, and we'll also add a banner and a loading bar to it, and also we'll implement a functionality which will take in the port which is already open and will give out the most probable service which is running on that port. So before I start, there was one thing which I wanted to mention, that in the previous video there was a starting latency, and that was happening due to the fact that the set default timeout was actually not here, but it was somewhere here after the first connection we are trying to make the first connection. So for the first connection, the default timeout is not 0.001 second, hence the time is being so much time is being taken at the start. So we could just put in here and save this, or essentially we could just put it out of the loop. We don't need to declare it every time, and it would run without the starting latency. It was pretty silly not to notice that, but anyways. So to implement multi-threading, first we import everything from the threading package. So from threading, it should be in small, not in caps. From threading, import everything, and then what we try to do is, for every port we'll open up a new thread, and that will take the target. The target of that thread would be a function con which would contain everything like these things. So we'll just cut this and paste this over there, and this would take in IP X. We'll call that, because IP is already declared, import X, and it will take in something which is called as a lock. I'll come to this later. And then we'll just change this to IPX port X, and if result is equal to 0, we'll append port X, and we don't need to print it. We won't be printing things right now, and else we don't do anything, so we don't need this. And now what we'll do over here is we'll start a new thread, and the target would be the con function, and the args would be a tuple. Args are in the tuple data type, and first would be the IP. Even though the IP is constant over here, but what I'm planning to do in future is maybe we'll take in multiple machines, like multiple IPs as input, and we'll iterate through the IPs as well. So in that case, the IPs would also be dynamic. So I'm just thinking what I want to do in the future, so that's why I'm just putting it over here, even though it is not necessary right now, but still. So args would be IP, and the port is dynamic, and then lock. Lock is something that we use to avoid something called as race conditions. Like, let's assume that there are two threads, and both are targeting con function, and one is scanning port 80, and other is scanning port 443. Assuming both are open, both will try to append that port to main array. So both will want like main array to their control. So to avoid that conflict of interest, we just use a lock. So that just helps us to avoid that. So first we define a lock using lock with capital L, and over here, after we have tried to make the connection, whether it is successful or not, we just write in lock dot acquire, and after the results are done, like it is appended or not, we just type in lock dot release. So this would be good. We just save it. And another thing which we would like to do is we would first obviously start the thread, and then we would like to join the thread to the main thread, so as to the main thread isn't completed first. The program doesn't terminate first and the threads are running in the background. We don't want that to happen, because we would create a summary at the end. So first all the threads should be completed. So for that, we cannot just type in t.join right here, because what would happen then is it would start the thread, and then this thread would be joined to the main thread. So essentially the program would be asynchronous even though we are using threading, because then it would wait for this thread to complete, then it would go back to the main thread. In that, we'll then iterate to the port, and we'll start the new thread, then we'll start that new thread, and we'll join that new thread. So this continues till for every port. So it would be essentially be asynchronous, even though we're using threading. So what we could do is we could actually make a new array over here, thread array, and over here we could just append the value thread array dot not main array, sorry, thread array dot append. We could append this thread, and after we have started every thread, we could just loop through the threads, as in for thread in thread array, and we could just join those threads. So and this should be enough, I guess, for the multi-threading part. Let's see. Scanner.py 192.168.29.1. Let's do till 200, and yeah, it's pretty quick. Like if you watch my previous video and you just copy that code and paste it, and obviously set the default timeout to be outside of the main loop, which was previously there, so as to not experience the starting latency, it is way more quicker than that. So, and I'll just remove this start. We don't need this. So 1 second. I'll just take maybe some bigger range and start, and we'll start this count from 1 to, let's say, 5,000. So it takes less than, I don't know, maybe about 5 to 6 seconds. And if you would have done that with the previous program, it would, I don't know, it would definitely take more than 20 seconds, or maybe 30 seconds, or maybe a minute. I don't know. It would take a long time because that was happening synchronously. So the multi-threading part is done. So now what we need to do is we need to create a banner. So first I'll just do one thing. I'll import OS and I'll import system, and I'll do one thing, os.system cls, so as every time I run the program I don't have to like clear the screen. So to create the banner, I'm using a third-party package called art. So we import art. You could just install it from pip, and we just print over here. Before that, let's do one thing. We could just erase these things, and we'll take in argumentative input, so we don't need these things. Or like we could just comment these out, yeah. And we'll print over here art.text, text to art, and then scanner. So this should print the scanner, yeah. Port start is not defined. Okay, we should make a sys.exit here because we don't want the further execution. So scanner, and just remove this for now. So yeah, scanner. You could also change the font if you want. You could make it block, even though I like the default font, but there you go, that's why I don't like it. And if you want to see which fonts are available, you could just like, once you have installed the package python-m art fonts, it would basically just list all the fonts available. I don't want to display everything right now, so I'll just go with the standard default font. So let me just check once again, and yeah, that is good. So after that, we will try to take in argumentative input. So I wanted os.system, but not here. It should be above the print, yeah. And then after this, we don't need this. And then we have an int variable. In that, we will store the argv, and the first value would be the name of the program. That would be scanner.py. So we don't need that. So we write in 1 colon. So let's just print this. And let's just system.exit to once again see what's happening. Yeah, right now we didn't call anything. Let's call it with maybe 1 2 3 hello and 9832, something like that. So all those things are registered. So then we need to check basically whether the format of the input is being matched or not. So for that, it's pretty simple. We just use a try catch block. In the try block, we just do a if not, and over here you put the syntax of the argumentative input. And I'm planning to do, I'll just tell you in the catch block, like if the syntax doesn't matches, we'll just accept the error, and we'll just print over here. I'll just print the format, and we will system.exit, yeah, and print over here within caps usage, and we'll do a /n small n, sorry, and I'll print a bullet over here so it looks good, 2022, and then it would be scanner.py -t, t would be the target, then IP address dash p, port start, and then port stop. So this will be the syntax. So if like the syntax isn't matching over here, so the first one should be -t, so inp 0 should be equal to -t, and the third one should be -p, so -p, inp 3 should be equal to -p. If this is not true, then we'll just raise error. So let's see, this should be working right now. So let's see, this should raise an error. Yeah, so don't raise actually an error, but we just print the usage. So this is good. And then what we need to do is we just need to copy down the values. Inp1 would create would contain the IP value, and port start would be within inp4, and port stop would be inp5, or 0, 1, 2, sorry, this should be equal to 2, that's what I was wondering, and this should be equal to 3, and this should be equal to 4. And another thing we would like to check is, it's pretty silly thing, but the port start should not be greater than equal to the ports greater than port stop. If it is, then the function should not be working because there is an error. It should be from port 20 to port 50, not from port 50 to port 20. So if port start is greater than port stop, we just raise an error. So let's just check all these things. Shouldn't work right now, yeah. And let's just give -t. Still shouldn't work, and still shouldn't work, and let's give -p. Still shouldn't work, and over here I'll just do x is equal to input working, and -p isn't working. This should also not work, and then let's do 10. This should also not work, and then 30. This should working. Okay, so we are good with this. So the argumentative input is also working. We just need to convert these things to int. So we are good here. So let's just run the whole program once to check whether it's working or not. Scanner.py -t 192.168.29.1. Oh, it shouldn't work, I forgot. And from port 1 to 1000, yeah. Okay, it still doesn't work. That shouldn't happen. What kind of error are we expecting here? What did I input the last time? Oh, I didn't get the -p. That's why. It should work now. Yeah. 80 and 4 holes are open. So it's working. And now what we need to do is we just need to make the loading bar. and that would be enough. And also that functionality, we'll get the service by port. So first let's try to create the loading bar. So I guess there is a third-party package which can be used to create a loading bar, but I'm planning to make one of my own because I think that is more suitable in this case. I forgot the name of the third-party package which could be used to make a loading bar in Python. 1 second, I'll just check. Anyways, there was a package, I forgot the name, but we are going to make one on our own. So for that we need to create another function, and that function would print the loading bar, and we are going to be using carriage return so as to update the loading bar whenever a progress has been made. So first we create a variable called scanned. Not over here, we'll just not try to clutter everything. We'll create a variable called scanned which would be equal to 0, and in the def con over here what we'll do is we'll just make within the lock acquire and lock release, we'll just make this scan variable global over here, and we'll increase its value. Scan would be equal to scanned plus 1. So let's do one thing. Let's while the scanning is being done, let's try to print it. Let's see whether we are getting what we wanted or not. Okay, so the port is done. Either you could do one thing, we don't need to do that. We could just type in the print bar function. So what it would do is basically we first need to define the function, and I'll just explain on the way while typing it what the function is. So print bar, and essentially what this function would do is that we'll try to use, like, I'll just show you, maybe like in, I'll just open CMD, and over here I'll just type in Python, and let's print in this, and we'll concatenate it with /u, and the ASCII code for block is we'll basically have 2 bars and the block would run through it, and it won't run through it, we would add the value of the block to it, and the value for block would be \u2588. So 2588, and we'll concatenate with space into 9 times, and we'll concatenate it with the ending bar. So this will give us this. So if we make this into 8 and into 2, we would have a progress, and if we make like this into 7 and into 3, we would have another we would progress once again. So this is the basic functionality which we are looking for. So first I need to do this. I need to have a constant messenger that is scanning, and I'll just put a little bit of space over here, and over here I will just put in the hyphen, then I'll put in the bar which is \u2588, and we'll multiply this by a variable called LV, which we'll define right now in a moment. Let's just keep it like this right now, and the total length of the bar would be 30. So in the starting case, LV would be equal to 0, because LV is essentially the ratio of the total number of ports which we have to scan and the total number of ports which we have scanned. Hence we had a scanned variable there. So we would essentially keep this into 30 minus LV, because 30 would be the maximum value, and then we'll just add a hyphen over here. So every time we every time this con function is done, we just call the print bar, and LV, as I said, would be equal to the number of ports which we have scanned, and we'll just flow that value, but first into 100, and by, we just do flow division by the total number of ports which we have to scan, that is port stop minus port start. And then we would, the main thing is basically we would end this with a carriage return, so that every time, like I had this example, right? So let's consider this this line. So when this line is printed and we end this with a carriage return R, so the cursor would be back here. So when we print this line, it would overwrite this, and this would look like this, and the progress, it would give an illusion that the progress is being made, that like the progress bar is moving. So we would do that. Let's see if this runs or not. So I'll just clear the screen, sorry, and let's see. Okay, there was somewhat of an error, and okay, once we are done, we should do one thing, is that this should be /n, and we need to add this. So okay, so it is going over the 30 space which I had defined for it. I don't know why. Maybe the ratio thing isn't working right now. One second, guys. Scan into 100 by port stop minus port start. So let's see the value of scanned every time. I'll just, it would be a mess. 1000. Okay. So let me see 1 second. I think there shouldn't be an error in this case, but I don't know why that is happening. So one second, guys. I had this planned, but it isn't working right now. Scan should be into 20, so let me just see. Into 30, sorry. So this should be working. Okay, I guess I need to do scan into 30. Let's see. This should work. Yeah, okay. You just need to get rid of, and yeah, +1 over here. And we'll see if there is any other error, but it shouldn't be. Yeah. So we have a progress bar ready. So this is good enough for right now. So another thing I would like to do is, the last thing is the ending of this function. It just prints like 80,443. So I would like to give it like a better, like a more comprehensive and a more detailed summary. So there is a function in socket package which is called get serve by port. So that essentially takes in the port value, and if that port is commonly defined, for an example, if it is port 80, so it would return HTTP, and maybe if it is a port which is not commonly defined, it would throw up an error. So what we could do is over here we would just print the scanning is done, is should be, and one more thing, it still shows scanning, right? So we could do this, that maybe in the last one when LV is equal to 30, I guess, if LV is equal to 30, we just, instead of printing one second, yeah, instead of printing scanning, we just print scan done, and the amount of space should be equal. So 1 2 3 4 5 6 7 8 9 10 11 12 13, and over here we have 1 2 3 4 5 6 7 8 9 10 11 12 13. So yes, and we could just put in 3 dots over here, 1 2 3 1 2 3. This would be good enough. Let's see. And okay, we need to put in if else over here. So if it is equal to this, else we do this. So it should work. Let's see. Okay, print shouldn't be double T. Yeah, it should work. Yeah, it worked. So now we only need to take care of the main result. So the scanning is done. We just want to print the scan results maybe, and just add another space and scan results. And 1 second, let us see how that looks. Yeah, and I'll just change the name from scanner to maybe like something else. I don't know, didn't have any other name in my mind, and I had already made a port scanner previously, and I had named that Raptor 2. So I'll just name this also Raptor, and yes. Yeah, good. So the scan results, and then we just call a function results res, that would just print in all the details properly. So we just call the function, and then what this will do is, it's on the top, this will iterate through the open ports. First it would check whether ports are, maybe if there is 0 ports open, so their length would be equal to 0. So if length of the main array is equal to 0, then we just print no TCP ports are open in the given range, and then we just do system.exit, and if it is not that case, then we just put a for over here for, let's say, p in main array, and then we put a try block over here, try, and service we type in by serv. And the reason I'm using a try block is, like, if the port is undefined, the service on that port is undefined, it will throw up an error. So we'll just catch that error if there is. Else the service would be equal to get serve by port, and port would be p, and we'll accept the error, and there is an error in this value of serve would be unknown. So this would be good enough for both the values, and then we'll just, and before this we'll just print one more thing, print port, and on a new line, or actually we don't need a new line, we have just printed a new line, port, then tab service. Yeah, then when we have both of the values, we'll just print them. So print port, and on a new line, we have just printed a new line, port, then tab service. Yeah, then when we have both of the values, we'll just print them. So print str port, and we'll just have a tab over here. We'll concatenate a tab over here, and then we'll print in serve. So let's see whether this is working or not. It should be working. Okay, no, it is not working. There is something with the, oh, obviously I used port over here instead of P. So now it should be working. Yeah, port, scan results, port, service, and 8443. I'll just add a new line over here to make it a little bit better, and I guess that would be enough for this video. Let's just run it one more time. Port 8443 and open. Okay, let's just do one more thing. Scanner.py and -t 192.168.29.1, and we'll scan from, let's say, port. Let's take a bigger range. Sorry, it wouldn't work anyways. So 1 to let's say 10,000. Let's see. So if this works, then the program is working. Let's see. Okay. HTTP, SSDP, unknown. So the port 443 should also be open. Maybe it's because of the fact that we had just made a request. I don't know. Let's just run it one more time. But anyways, the scanning was really quick. I'll just make another request. Let's do this one from, let's say, 500 to 10,000. We actually did till 10,000, so let's do another range, like maybe 1,000 to like 15,000. This shouldn't work. Yeah. So okay, that is too big of a value. I had actually put in, let's see, unit 10, 100,000, 10,000 lakh. Okay, I had put in a bigger value. Yeah, this would be the value which I was looking for. So if this works, then everything is working fine. Port 1,000 to 15,000. So if this is working, then all good. Let's see. Yeah. So all of these services are unknown. I guess it would be something, I don't know. I'll have to look it up. But anyways, this was how to create a much better TCP port scanner. So even though it is still there, many more things which can be done. Maybe we could implement. Another thing which I wanted to implement was ping sweep. That is, we would send ICMP packets to the whole subnet, and we'll see which machines are alive. Then we'll put all those machines into an array, as I told, I think, in the beginning of the video, and then we'll scan all of those. So we could do that. We could add another feature like stealth scan, which we have in Nmap, and then many more things could be done. But I think this would be a good enough port scanner. So maybe in the future videos we'll try to even improve on this also. But I think this is good enough.